think we can start. We have got
This call is now being recorded.
sufficient number, so actually we can start. So after the last class, do you have any doubt? Anyone?
No.
Okay. So in the last class is basically some introductory kind of thing we have discussed only. Okay, regarding how the civilization is progressing, and in those cases actually how actually the different mechanisms, machine, etc. How it is taking part there. Okay. So those things already we have discussed. So now after that we have also discussed about mechanism and machine. Then we have said when we will be calling the one as mechanism, when we will be calling one as like when I'll be designating as can say uh, machine. Okay, so those things we have discussed, and I told you to go through like machine versus engine, okay, and machine versus structure. So I believe also we have discussed about machine versus engine, so those things I believe you can consider as a homework. So now if we discuss about machine versus structure, then actually what happens in the case of machine, so there is kind of relative motion between the members. So those members are the one, okay, which are you can consider like link, okay, and they are the main or the elementary thing that is present in a kind of machine. Okay, so which is comprising of so many mechanisms and all. So in between the members basically we have got relative motion in between. And if you consider a structure, so in that case there is no relative motion between the members. If you consider like a structure example, you can consider the building, bridge, etc. So now if you think in the building, okay, so whatever we call as the building, okay, this home, etc. So there if you think the different members are having relative motion, that means kind of it is shaking. So then you can consider what is going to happen there. So you will be afraid to stay there. Similarly, if the bridge itself is kind of rocking, or it has got relative motion between different members, so it will be disastrous. So that is it. So this machine, it transforms this available energy into certain kind of useful work. All of you already know. So then really some motive power or the available energy is there, and by the use of this machine we can get some useful work done through it. But structure, it doesn't convert any kind of available energy into any work. Okay, mainly the members in the case of structure, they are meant to take up the loads only. It is going to bear the loads. But in the case of machine, so apart from that, okay, basically they are meant for transmitting motion and the force, so that some required work done can be obtained. Okay, so example all of you can take machine, car, or the machine tool, that's the lathe machine or milling, chopper, etc. I consider as an example of machine, and the different frames, building, etc. you can consider as the example of your structure. Okay, so now prior to going to this plane mechanism, what is plane mechanism or planar mechanism, or what is space or spatial mechanism, so prior to that I'll be going through some of the basics of, you can say, the different terminology, etc., which we use in the case of this while designating any kind of machine, mechanism, etc. Okay, so now all of you by this time already know this mechanism. They are kind of the building blocks for the machine. Okay, the machine may comprise of a single or several mechanism to get a certain useful work done. And now in the case of mechanism, whenever we are discussing about mechanism, so it is also comprising of so many leads members assembled in such a way that it can give certain relative motion, predictable kind of or constant kind of relative motion between them. So there is certain degree of freedom that will be involved there, and there will be certain members, different members will be linked, or you can say joined together so as to form that particular. Okay, so now in that particular case we'll be discussing what is link, also known as the kinematic link or link, the same thing. Okay, or you can say the different pair, what we understand the pair. Okay, so those things we are going to discuss. Okay, so the initial thing we are going to discuss. So this link, so or also known as the kinematic link. This word kinematic also is involved sometimes.
Sir,
Yes,
not
yes.
audible, sir.
Okay, so to others, am I audible to others?
Yes, now, sir, it's audible, sir.
Okay, so maybe some network disturbance are there. Okay, so kinematic link, okay, also known as only link or kinematic link. So similarly, after that we'll be discussing about pair. Okay, what after link, like what will be the link of calling as pair. Okay, so like that. just wait, students. Good morning. Oh, yes, sir. Okay, sorry for the disturbance. Some passing on student, they came for some work. Okay, don't worry. Okay, so link or kinematic link, or then we have got pair. Then will be the next higher thing is kind of chain, also known as kinematic chain. So they are all like the meaning is similar. Okay, kinematic word if we use or don't use, then ultimately it means the kinematic link only, kinematic pair, kinematic chain only. Even though we only call as link, pair, chain. So now this link, how can we define it? So basically, this link is a resistant body, or it can be a group of resistant bodies also with rigid connection which prevent their relative motion. Okay, in between, that means it in between this. Okay, if it is a kind of group of resistant bodies, then there is no relative motion in between them. Okay, and it can also be defined as a member or a combination of members of a current certain mechanism. So you can consider like as if this is the building block for it. Okay, and what does it do? It basically connects other members and having relative motion to them. So if we consider two links, it is kind of the kind of members, okay, which is going to give you the ultimate thing. Okay, so this link we also call as already I have discussed, either kinematic link or element also. Okay, it is the basic thing that is there in this case. So now there is one very important kind of mechanism known as the slider crank mechanism, which will be coming across quite often. So it has with respect to this, I can will be showing what are the different links which is there. Okay, so now prior to going to this particular kinematic of this slider crank mechanism, so I just want to tell you one thing. So see, there will be so many mechanisms you will be coming across, and those different mechanisms will have different shape and size. Okay, but it can be ultimately broken down to some simple diagram, and those kind of line diagrams we call it as, hello, am I audible to all of you?
Yes, sir.
Okay, so those diagrams basically we call it as configuration diagram, or sometimes kinematic diagram also. Configuration diagram. Sorry, I'm writing in laptop is kind of difficult. Configuration diagram. Okay, so also known as kinematic diagram. So what they do basically, those diagram we use those simple diagram to represent the complex mechanism. So now here in this particular case, whatever you have, you can see here in this right hand side. So this is the configuration diagram or kinematic diagram, or sometimes even known as the line diagram. We don't generally use the word line diagram, but configuration diagram or the kinematic diagram is the proper word to use. Okay, so here this configuration diagram, this is the configuration diagram for slider crank mechanism. So here we have got four links, four basic elements. Okay, so what are those? So these are, we have got one link which is known as the crank. This link is known as crank. We have got this link number as 2, which is known as the connecting rod. This connects this particular crank to this particular slider. So this connects it, and this particular link is connecting rod. So just like I have drawn this particular thing T, this is the third one is known as the slider. Or if you consider the piston cylinder kind of arrangement, which is generally there in the different cars, etc. Okay, in the engine part, so that is the piston, equivalent to the piston. And we have got frame or guide in which it operates. So now how this particular slider crank mechanism works, okay, definitely we'll be discussing, but right now you should know that basically we have got four elements here in this particular slider crank mechanism. So this mechanism will be coming across quite often. This is one of the very important mechanism, and how it works just after the types of links, type of pairs, etc. After discussing those things, I'll once again come back to this. Is it okay? But right now you must know that there are four different elements that is there: crank, then connecting rod, then the piston or the slider, and the frame. Okay, we number them with different numbers. Generally the uh, this frame or the guide, okay, or the fixed element we generally number as 1. Then sequentially we keep on numbering the different links or the elements which is there in the mechanism for analysis purpose. Okay, those things we will come across later. So right now up to this much, it is clear what is link. Okay, so just you can respond, no problem. Link, it is kind of the, just like if you think of the making a building, then the bricks are kind of the elementary thing. So just like in the case of mechanism, the links are the elementary thing. Okay, so now type of links we can classify like in different ways. So one category of classification may be categorizing them like the rigid link, flexible link, or fluid link. So now how can define the rigid link? So this rigid link, they will not undergo any kind of deformation while they are transmitting motion. So basically the thing, as we have already discussed, this mechanism we use for transmitting the motion or force from one place to another. Okay, that means ultimately from one link to another. So there will be certain input portion, there will be certain output portion that you are going to get. So if it is a rigid link that we are talking about, or the rigid member, so it is not going to undergo any kind of deformation while it is transmitting motion. Like in the case of, if you consider the slider crank mechanism as the example once again, then the crank which was there, which was the rotating member actually, then the connecting rod which was connecting the crank end point of the crank to the slider, similarly the piston, okay, all those were kind of rigid links, so they will not undergo deformation in their shape. Similarly we can have flexible link which can undergo partially deformation, okay, partial deformation while transmitting motion. Like if you consider the spring, okay, maybe the belt or the ropes, okay, that you have seen, so during its operation, so the spring, belt, etc., it may undergo certain partial deformation, so those will be considered like the flexible kind of link. And there will be another category you can consider like the fluidic link. So here in this case the motion is being transmitted by the action of fluid or the fluidic action. So you can consider about the, take the example of different hydraulic brakes, hydraulic press system, all those things. So they are basically through the fluidic action, through transmission of motion, okay, that happens. Similarly, apart from categorizing them like the link like rigid, flexible, fluid, we can also classify them like binary, ternary, quaternary, etc., etc. Similarly in the higher range we can go depending on how many ends or how many ends are there where we can attach other revolutor turning pairs. Okay, so as we have already discussed, these links, they are nothing but the building block. That means one link will be connected or joined to another link in a certain fashion, then that will be connected to another uh, link depending on what is the kind of mechanism, etc. Okay, and they will be the connection will be there, and some relative motion also will be there, which is kind of predictable or constraint kind of motion. Now binary, ternary, quaternary, etc., how we can define like that? Okay, so binary link, what will be binary link? You can, in simple term, you can draw like this. It can have, in actual sense, it can have different shape, okay, which I'll show later on. So this binary link, basically it has got here at its two ends, that means I can connect some other element, so that's why the name is binary. We have got this end, we have got this end where two other links can be connected. If I connect, if I join another link here, so I can do like that. Similarly I'll be able to join some another link here also. Okay, so this particular link is a binary link. Similarly, if you consider this join, okay, so for this particular link, so we have got one point here where I can join another link, similarly one here, so that will be another binary link like that. Similarly we can have ternary link. So from the name itself we can know, okay, so it will have, here I am showing like, sorry, by this circle, okay, so this and at this and similarly at this and we can connect some other member. It's possible, that means I may connect some other ternary, binary, or whatever type of link here. It is possible, I can connect one, okay, maybe I can connect something here, okay, so maybe I can connect something here. So ultimately 1, 2, and 3 possible position where I can at these 3 ends are there where revolute or turning pairs can be placed. Similarly, I can have quaternary link depending on, because we have got 1, 2, 3, 4, 4 numbers of links, okay, 4 number of position where other link can be. Now, how I can know that means this one is a ternary link or this one is a quaternary link, but not 3 different binary links or 4 different binary link in this case? How I can be sure? So generally, to designate ternary or quaternary link, so to make the sense that this whole thing is a single entity or this whole thing is a single entity, to make this particular thing clear, we generally mark it by hatch mark. Okay, we show like this. Okay, if I show like this, automatically it is understood that this is a ternary link. Okay, ternary link. So this one is a binary link. Okay, how it is binary? We have got 2 positions. Okay, 1 and 2 position where I can 2 ends where I can use connect to other revolution. Similarly, 3 possible position. In this case, how many positions are there where I can how many ends are there where turning or revolute pairs can be placed for this case? Anyone? How many? Who will give me the answer? Don't be afraid to answer. Okay, just try. Hello, I hope I am audible.
Yes, sir.
So what will be the answer for this quaternary link? How many possible positions are there where I can join other type of links, other pair, okay, other turning pair or different. For this case, we have 1, 2, 3 and 4. Yes, correct, 4. Okay, 4 positions. So, and to make the sense that it is a single entity, not 4 different binary links. Someone may think like, okay, I am drawing like this. Okay, sir, drew like this, and because of that, it should be like just like previously we have shown here in the case of binary. Yes, we drew like this, right? The binary one. Okay, so you should not think that suppose this is 4 different, suppose 1, 2, 3 and 4. You should not think like this is a 4 different links that is there. So, okay, but to make the things clear, that means it is a single entity, we do like this, we show it with hatch marking. So while drawing configuration diagrams are the diagram which are drawn in simple form, and they are used to describe or draw the whatever is the type of mechanism in its simple pictorial way. So while drawing the configuration diagram, in if it is if some of the links are shown with hash mark, then you must understand that this is a single link, not 4 different binary links, but it is a single link. Understood up to this much? Is it clear? Let me know. If you people respond, then it will be easy for me to just go ahead. Okay, okay, thank you. So next is pair. So now link is done. Okay, now next higher thing is pair. Okay, so with this pair we are not talking about the whatever pair you people like. Okay, that is, we are not talking about couple and all. Okay, but the meaning is something like this. Meaning is something like, means from pair, all of you understand, that means 2 things are there. Okay, so now this kinematic pair we can define like it's a joint of 2 links and they are having relative motion between them. Okay, so whenever 2 links are joined at the joint, so we have already seen that in the links, at the end of the links, it's possible to join some other links. So this pair means join of 2 links and they must have relative motion between them. It's not like, suppose if you think, suppose this is one link. Okay, let's consider link 1. Okay, this is link 1, and if I join here another link 2, and they have got motion relative to each other, relative motion is there, then it's a pair. But if suppose this is a link, consider, okay, and this one, and I have actually welded here. Welding is being done here. Okay, then do you think there will be any relative motion between them? Will it be able to move with respect to each other, this portion and this portion? I have welded here. I have done welding. What do you think? Will it be a kinematic pair? Shankar, what do you think?
Thinking.
Huh? Yes, will it be a kinematic pair in this case if I have welded here? So now in that case it will not be a pair, but it will behave like a
Not correct.
single link. No, yes, correct. So it will not be a kind of pair, okay, because there is no relative motion possible between this part and this part, which is the case in this particular case. But the thing is, will be behaving like a single link. Now at this end and maybe at this end, it will be possible to join them. So now it has to be joining of two links having relative motion between them. Okay, and in general the motion between the links is completely or successfully constant. Okay, so the constant type of motion will later on we'll discuss. Don't worry. So now with respect to the, once again coming back to the, what is the name of this mechanism that we have previously drawn? What is the name of this mechanism that we have discussed? This is the configuration diagram. Previously we have shown in the left hand side. Now the slider is on the right hand side. So this is the slider crank mechanism, if you can remember the name. Okay, once again it is coming. Now here we have said that there are 4 links. Link number 1, that is a fixed link or the guide. So here as well as here. So link number 2, which can rotate, this is the link 2, it can make complete revolution like this. Okay, so this is known as the crank. And we have said that this link number 3, which is connecting the crank and the slider, okay, this is the link number 3 and slider is link number 4. So there were 4 links. Now they have got connection here. Yes, so this is kind of pin joint or the hinge joint that we call it. Okay, so this is now in that case, if we think what is the type of pair they are constituting, so you can say, so this link, this is number 1, this crank is number 2, yes, this link is number 3rd, and this is number 4th. So 1 and 2 if you consider, so 1 and 2, this combination if you consider, so it is something like this. Yes, one we are drawing like this is the fixed portion, and we are showing that this portion actually we have got this kind of joint, we call it as pin or hinge, pin, pin, or also known as hinge, hinge. Okay, so pin or hinge joint. So now from the look you may think what kind of relative motion is possible between them. So now about this pin, it is something like this, it can rotate, it can either this way or that way. Okay, this link can rotate. So this kind of thing, so this is suppose fixed link number 1, we have given this as number 2 link in the case of slider crank mechanism. So now this link 2, it can rotate relative to link 1. So this is going to 1 and 2, it is going to constitute a kinematic pair, and the type of this kinematic pair is known as revolute or turning pair, depending on the type of movement that is possible. Similarly, if you consider this link 2 and link 3, that is also, there is one again pin or hinge, pin or hinge joint that is there, and generally pin and hinge joint, it allows for this kind of turning or revolute kind of movement. So once again that will be turning pair. Similarly this 3 and this slider 4. Okay, so at the end, this is the 3 and end of link 3 is connected here, joined here at this, okay, with a pin joint. Once again this 3rd link and the 4th link, that is the slider, that is going to make another kind of turning pair. Okay, so 3 turning pairs we have discussed. And if you consider link 4 with respect to link 1, so this is 4 and this is 1. Once again there is another one, let's consider this portion, okay, right hand side portion, this portion. So this is the slider that we have. This is the slider, okay. Slider, from the name itself you can say slider slides along this guide. So the relative motion is sliding kind of movement, so it gives you a sliding pair, okay. So that is the thing. Understood up to this much?
Yes, sir.
Okay.
Yes.
Now I am going to show you a slider crank mechanism, okay, how basically it is working, okay. Maybe any kind of motion you can say. Let's consider I am just showing this particular one, okay. So how many links are there? Okay, so as I have said, so the loop, actual loop of the mechanism, it may be different, but what we draw it in a simple form, and that simple form is known as what? That simple form is known as what? Configuration diagram. Okay, so here in this particular video, I'll just run it. Okay, don't worry. So what are the, how many links I have said that is there in the slider crank mechanism?
Four.
4. Okay.
Four.
How, what? Yes, correct. What are they? We have got the crank, which I said that this link, one link that can rotate, kind of crank, and at the end of this crank we are connecting the crank to the slider, okay. So that is another link, okay. Then slider itself is another link, and the slider is being guided on a particular guide. That means this slider can only have reciprocating or to and fro kind of movement in this particular slope, okay. It is being guided here, there is no other way it will be able to move. So I am just showing it. So now what you can see, so this blue portion, this one, okay, from the left hand side I am coming, okay, you can see this particular round thing, okay. Now in actual sense maybe the body it might be like this, okay, but while actually we are drawing it for our simplicity of showing, okay, we are drawing it something like this, because the we are interested in the motion, how it is behaving, okay. So you can see we are drawing like this, the same thing I can show like this. So this is the fixed portion, and which in this particular case you can see here there is no movement, but here it is fixed, this particular blue thing, okay, blue one, and it is rotating like this, okay. It is able to make complete revolution, right? Okay, so now what we have up to how much I have shown, okay. So this can rotate, okay, about this particular pin joint, as it is a pin joint it can rotate, okay. So now this end of this particular crank, okay, this is known as the crank, okay, this is the fixed portion, okay. Now it is connecting the slider to the crank, this is the connecting rod, okay. And this is the slider, from the name itself you can say it can have sliding, it will have sliding movement when this crank is being rotated, because the motion transfer it take place. And why motion transfer is being taking place, okay, because these are connected, okay. So had it been like one link like this, and there is no connection between, suppose this is the crank, and there is no connection between the crank and this particular connecting rod, do you think there will be any kind of motion that is possible? It is not connected, that means no connection is there. So it will behave like two independent entities. So this if you, even if you give some motion to it, so it will not be transferred to it, okay. So through this particular, as they are making the kinematic pair, actually their corrective motion is being connected, okay, transferred. Now if you consider this particular slider, so if we don't guide it, okay, if I don't provide any kind of guidance to it, so I cannot be sure actually what is in how it is going to behave, okay. So now this guide actually makes the motion constrained, that means along this portion, along this, because of this particular guide, so it will be constrained or limited, okay, to move along this direction only. So this is the configuration diagram that we are drawing, but actually it may look something like this, okay. Now I am once again showing it, okay. Now you can see here this link, with respect to this portion it is turning, okay. So turning pair, this blue portion and this brown portion, if you consider once again, because of this particular white, that white thing, that is the pin or the hinge joint, okay, here also it will have, it is rotating with respect to itself, okay, or turning we can consider, okay, turning with respect to this link and this, Okay, so once again turning to this and this. Similarly, now if you consider this brown portion and the slider portion, once again you can say there is one hinge joint that is there, and during the course of movement of this particular blue crank, so here also some motion is turning portion motion is there. So this and this is once again making turning point. And now if you think of this slider, okay, and this blue portion that is the guide, okay, so now along this particular direction only to and fro kind of movement that is there on the sliding, so it is sliding, okay, slider is sliding, crank is having rotational motion, the motion from the crank is being transferred to the slider through this particular connecting rod, it is connecting them, okay, and in which way the slider is moving, slider is being guided by this particular guide or the frame, okay, in because of this particular as the guide is there, so it cannot move vertically or like that, okay, or only in this direction it is permitted to move, okay, so this is a kind of constrained motion, okay, understood to this much. So what are the application of this? So this particular slider crank mechanism has got so many application, okay, in different scenario. One of the very important one is in the, all of you already know, that is there in the all of you might have seen the, you can say, any kind of car, okay, so there whatever is the basic mechanism that is there, you might have heard about piston cylinder, and in the case of your thermodynamics, basic thermodynamics, etc., there ultimately that whatever piston cylinder that you are talking about, it is nothing but it's a kind of the inherent mechanism is the slider crank mechanism that is there, okay, so reciprocating movement of the particular crank has been transferred to the has been given it gives you whatever is the up and down kind of movement to that particular piston, right, in the case of kind of a particularly the cylinder, okay. So similarly there are some words that will be later on using like inversion of mechanism. So you'll see like but this main mechanism that is the slider crank mechanism in some form, okay, certain modification we can, there will be, it will have different application, okay, it will give rise to some different kind of mechanism, okay. So like in the kind of even hand pump also there is one inversion that is being used, okay. So similarly there is some other. So up to this much, any confusion? All of you have understood how basically this works, slider crank mechanism? Let me know, this is very important one in your day-to-day life, in your engineering application, you will be always coming across this one of the very basic yet very powerful mechanism. Let me know, have you understood or not?
Yes.
What others?
Yes, sir.
Okay. Now all of you are, if someone asks you about slider cam mechanism, you have got the confidence, that means you will be able to make people understand, right? Now why generally we show this portion with, sometimes you will see some circles are drawn here along the crank, okay. So basically this shows the locus of the end point of the crank, okay, this particular point. So if it rotates, makes a complete revolution, ultimately this will move in this particular circle, okay. So that's why we show it like this, okay. And we have to show motion to the slider, that is reciprocity, okay, to and fro kind of motion that is there. And how many links now? Now this is also is a fixed link, okay, that is the number one. Similarly this frame also is kind of fixed. If you show like this with this hatching kind of thing, we automatically understand that this is a kind of fix, okay. In the configuration diagram we show the fixed link like this, okay. So and fixed links are always numbered with the same number, okay. Later on I will discuss why it is numbered the same number, why not different numbers. So this is the whole thing. So next link is this one, okay. You can either go from this side or that side, there is no hard and fast rule about that, but in general we start from sliders, okay. Second one is slider, third link is this connecting rod, and fourth link is basically this slider, okay. And this guide or the frame is the once again fixed, okay. These are the four links. Now there can be different classification of the kinematic chain, this pair also, okay. So it can be classified based on the, we can, based on the type of contact, that means what kind of contact is there in between the two links which is making the kinetic pair. Similarly type of constraint I am saying how basically it is being held, okay, something like that. And the type of relative motion, Now because of this particular type of joint, what kind of relative motion it is permitting? Okay, so based on the type of contact, we have got lower pair and higher pair. Okay, for this lower pair and higher pair we'll discuss. Okay, it has got basically, depending on contact, it is kind of area or surface contact. Okay, area or surface contact, that is known as lower pair. Okay, and what is higher pair? Actually, higher pair in the case of the, if the two links, it has got either line or point type of contact. That means only at the connection, if it is kind of the connection between the two links, which is ultimately giving rise to the pair, if it is kind of line or point kind of contact, then we call it as, based on the type of contact, this type of pair is known as the higher pair. Okay, but if it has got surface, then throughout the surface, okay, at a certain portion of the surface or the area is in contact, are in contact, then it is lower pair. Okay, also sometimes there is another word sometimes we use based on the type of contact, that is the wrapping pair, but it is not always it is categorized like a single the different type of pairs. So wrapping pair sometimes also use. So we can consider the example of belt and pulley. Okay, so over the pulley, basically the belt is being wrapped. Okay, and that kind of pair sometimes known as wrapping pair. But in general, type based on type of contact, we call it as higher pair and lower pair. Now based on the type of constraint, okay, we have got closed pair or unclosed pair. That is how they are held together, whether they are kind of mechanically closed or kind of unclosed formation. Then based on that, we call it as closed pair or unclosed pair. So mind you, so it is not constant. Okay, just like the universal gas constant or some other, the word is not constant but constraint. CONSTRAIN. Okay, not a constant. Okay, generally that you use in the mathematics. Okay, it's not constant but constraint. Okay, it's okay, and similarly depending on the type of relative motion, that means how, due to the connection between the two links which is forming the kinematic pair, what kind of motion it is permitting. Based on that, we have got a sliding pair. Okay, just like in the case of your slider crank mechanism, we have seen the slider with respect to the guide, what kind of movement it has got. Anyone? So that is sliding or to and fro kind of motion it was having. That is nothing but a kind of sliding motion. So that kind of example falls under the sliding pair. Similarly, we have also seen like the hinge joint or pin joint. They are giving rise to the turning kind of movement between the two links. Okay, so that kind of pair will be known as the turning pair. Similarly, there is kind of rolling motion that is also possible between two elements. So that kind of motion pair will be called as rolling pair. Similarly, if you consider the example of screw and nut and screw, okay, whatever motion, I believe all of you have used a screwdriver in maybe in your home or here in the workshop or like that. Okay, so you might have seen how basically the movement is there, kind of helical kind of movement. Okay, so that kind of motion, if there is, it is there in between two links. Okay, so that is known as the screw, that pair is known as screw pair or also sometimes helical pair. And also we have got like if you, those who play video games etc., you have seen the joystick. Okay, so whatever is the joystick motion that is there, you can give rise to give in the different direction, right? So kind of there is a spherical pole that is there at the end of or socket joint that is there. So that's kind of example, it falls under the spherical pair. Okay, so that is these categories you have understood. Let me know. Yes or no?
Yes, sir.
Okay, thank you. So now coming to the definition of lower pair, higher pair, already I have told. So a pair or link having surface or area contact, it is nothing but between the members, it is lower pair. Okay, so generally the contact surface of the two links are similar. This is important. An example you can consider, maybe if a nut that is turning on the screw, okay, it has got surface contact. Okay, similarly if you consider a piston and a cylinder arrangement, so when the piston is reciprocating up and down or to and fro in the cylinder, inside the cylinder, the contact between the piston, outer surface of the piston, and the inner surface of the cylinder, that is also is a kind of area contact or surface contact. So they will consider, they will make lower pair. Similarly, later on we'll be discussing about universal joint. So that is also kind of, they fall under lower pair, etc. Okay. Similarly, higher pair, as I have already told, point or line contact between the links. Okay. So that is kind of higher pair. Okay, you can consider the cabin follower, maybe the gear, etc. Those falls under the example of higher pair. I'll show you, don't worry. Okay, so whatever always we are saying na pin or hinge, so you can see here in this particular field. Okay, so already I have seen the different kinematic pair. So revolutor turning pair, which is having pin or hinge, as you can see the blue portion and the red portion. Actually here it has got kind of hinge or pin, so because of this actually it can, this can rotate with respect to this. Okay, this blue red portion, red link, can rotate with respect to the blue link. So here this is a kind of revolutor turning pair. The pair is revolutor turning pair, and the type of joint that is there is the hinge or pin joint. Similarly, we can also have slider kind of joint, or sometimes also known as the prismatic pair. So these two you can consider the two different colored portion. Okay, you can think of within this particular rectangular portion. Okay, that rectangular bar is there along the rectangular hole. So only in this direction it can have to and fro kind of motion. Okay, this is once again once again is a type of constraint motion, but you can see the type of motion that is there is kind of sliding. Okay, so this is the sliding kind of pair that will constitute, and this joint is kind of, if you consider with respect to joint, then this kind of slider joint. Okay, and if you think of the helical pair or screw pair, so all of you already know screw and nut, that combination. I believe all of you have seen the helical groove kind of thing that is there. Okay, so this way, once you, if it can be right-handed or left-handed screw, depending on how you have cut the threads on that. Okay, and if it is clockwise, if you are rotating, and if it is going inserting through it, okay, then it's kind of right-handed, or otherwise it is kind of left-handed. If it is anti-clockwise rotation is giving you the forward movement. Okay, so I believe all of you already know those things. So it is kind of screw pair or helical pair. Okay, similarly the spherical pair, also known as sometimes globular pair. So here you can see here. Okay, so what kind of movement it can have? Three types of degree of freedom it can have. So in all direction it can, we can give the this way, that way, that way. Okay, you can give the motion. Similarly planar pair or flat pair you can have. So if kind of sliding motion only, sometimes also specifically called as planar or flat kind of pair. Okay, so if this kind of situation is there, one surface, one contacting surface is sliding over another one. Okay, both of them are planar. Okay, then I can also call this like, we can also call this like planar pair or flat pair. So I told you that I am going to show you some example of higher kinematic pair. So it has got, so this all here it is surface contact or line contact, if you consider these two flat pair. How link 1 and link 2, if you consider one blue as suppose link 1, red portion as the link 2, what kind of contact they have? Throughout the surface they have, or the area they have contact, or only at a line or point? Who can tell me? So throughout the surface they have contact, right? So that kind of, it will fall under what? Surface or area contact. It will fall under what? Lower pair or higher pair? Who can tell me? So it will fall under not higher, it will fall under lower pair. Lower pair means area or surface contact. Higher pair means line or point contact. So here surface or area contact is there, so it will fall under lower pair. Similarly, if we discuss about the, suppose you can see this pin, right? Pin joint. Okay, if there is pin joint, so here it is making higher pair or lower pair. Who can tell me? The surface or point contact, or line type of contact, or through the surface it has good contact. First you check whether it is surface contact, surface or area contact, or whether it is line or point contact kind of thing. What type of contact?
The point
Point,
contact,
sir.
sir.
Point.
Point, or here it is the connection, okay? It is being embraced, you can say like that, okay, throughout. So surface or line now? Surface or point?
Point, sir.
Why point?
Point, sir.
In actual sense you go for, okay, don't think that we are using the word pin or something like that. That's why I should say like point, okay. The actual look is something like this now, something is being inserted and it is being wrapped around there. So now it is the surface, or surface that is there in contact, or it's a point that is there in contact. You consider, let's consider two.
So the point is in contact.
Only point, it is being wrapped around, you consider like that. Yes, then it will become surface, right? Throughout the, if you consider the blue portion, okay, and if you consider thickness of it, I am just zooming it, okay, you can see. Yes, now throughout it, while actually the red portion it has also got certain thickness, okay, and when it is inserted there in this particular bulging outward kind of thing, okay, the hole was there in this, just like this case the hole is there. So here in this red portion also there was the hole, okay, and that is inserted there, okay. Now you tell me, it was the whole surface that is wrapped around that is in contact, or just some point or something is in contact?
So the whole surface.
Yes, the whole surface is in contact. So surface contact means lower or higher, what, surface or area contact makes it lower pair, okay. And if it is point or line, that is only there is there that is in contact, then it makes higher pair. So some example of higher pair, like the gear, okay, to take gearing, generally the normal gear that you see, okay, spur gear, etc., okay. Similarly cam and follower, those are having the contact is kind of either line or point kind of contact, okay. Then they will form then higher kind of pair, higher kinematic pair. So you can see how it is kind of higher pair. If you think of this portion, okay, suppose let's consider this. This is actually the cam, this is the follower. Here it is exaggerated, two followers are generally shown. Later on we'll be discussing in details. But if you think of this portion, okay, and this portion is something like, okay, this portion is one view, this is like this, okay. If you think kind of in a 3D kind of view, okay, this will be something like this, okay. So now this portion is in contact with, suppose, the outer portion of the cam, okay, and it has also got certain thickness, okay. Now here it is making, or another view if I draw, it will be something like this. Now from this view it is kind of point contact, line contact, surface contact, what kind of contact from this figure? If this is the cam, let's consider the cam, let's consider this to be the follower. There the contact is here, right? The contact is somewhere here. So now if you think like this, it looks like kind of line, point, line, surface, or what kind of contact? Anyone? What is the loop?
Line, sir.
No, from the loop only, yes, correct answer will be ultimately line, okay. But just from this particular loop, in this view it looks like a point, okay. Now if you consider the whole thickness of it, just like here I am showing, ultimately the line, okay, throughout the thickness if you consider, okay, then it becomes line contact. Yes, this point, okay, this is the kind of point, okay. Now the thickness if I consider whole thickness, okay, along which the connection is there, contact is there, so in that case it will be kind of line. So line contact means higher pair or lower pair?
Higher, sir.
Correct. higher pair. Okay, similar is the case for this one. Okay, similarly is the in this case of gear. Okay, the two teeth. I believe this is one teeth from the mating gear. Okay, this is another gear. Okay, bigger and smaller. So wherever there is contact, actually the surface. Okay, actually only along the pitch line. Actually it has got the contact. So that also once again generally makes the all in contact kind of thing only. Okay, so this also is a example of higher pair. Okay, similarly here I am showing once again the example of cam and puller which is being used in a operation of a particular valve. You can consider generally the opening and closing of different valves that is there in the IC engine, we go for cam and puller engine. So with the help of this motion from here, the motion is being transported to this particular follower portion. From here the rocker arm is there and the valve is being operated. Okay, so those things in details how cam and puller operates we'll discuss in the next classes. Okay, so for today up to this class will stop. Similarly these things already we have discussed. Closed pair, here the elements of a pair are held together mechanically like in this case. Okay, all lower pair, some higher pair, etc. Similarly unclosed pair, cam and polar, the open type cam and polar you can consider like the unclosed pair. Okay, similarly sliding pair, turning pair, etc. already we have discussed. Rolling pair, how these things. Okay, because of the type of motion only. Okay, so with this we'll stop here for today. So thank you everyone. So I'll be taking just let me know whether you have understood the basic concept you have understood or not.
Yes, sir.
Okay, so
Yes, sir.
okay, thank you.
Yes, sir.
Okay, then
Yes,
I'll be
sir.
taking the attendance. Okay, just respond to your name calls. Nilutpal, absent. Then Shankar,
Present, sir.
Harsishman,
Present, sir.
Rehan,
Present, sir.
Partha Patir,
Present, sir.
Rishikesh Basumatari, absent. Permiki, absent. Nahosal,
Present, sir.
Teja, Teja, absent. Rishikesh Nath, absent. And Emil, absent. What happened to Emil? He has not joined the last three classes. So if you are in contact with him, just tell him to attend the classes. Okay. So with this, we'll stop here. And thank you everyone for joining.
Thank you, sir.
Thank you, sir.
Yes, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.